Hello viewers, welcome to my channel Science of Technology. In today's show, Rocket Monday, we're gonna talk about Dragonfly from NASA. So let's dive right into it. So what exactly we are talking about? Basically, it's a mission to Titan. Now, like, why the heck we want to go to Titan? One simple reason: Titan is one of the largest moon of Saturn. Now, Saturn have many moons. That's why the largest actually means something there. And Saturn is the basically Titan is the only moon known with an atmosphere. Now, be mindful when you're talking about celestial body atmosphere. Like almost everything has an atmosphere. It's just like, is it significant enough to warrant heat shield, or significant enough to warrant flying there or something like that? This puppy is the only one where you can compare it to Earth. Basically, it's more dense than Earth. Like the only other place that will come to mind easily would be, like, let's say for example, Venus. So you get the point. Like, as a moon, as far as moon goes, this puppy has a very significant atmosphere, bigger and heavier than Earth's atmosphere, and its gravity is very light. So if you want to understand this in this way, 9.8 meter per second square is Earth's gravity. This puppy is at 1.3 meter per second square. So very light boy. And this probe that we want to send there, the interesting part of it, it's completely flight based. Basically, it will be deployed based on its own flight system. If it fails to fly, it will crash. There is no backup. So we are trying to do similar thing with Mars helicopter. However, that's an add-on mission. Basically, we have a rover, everything is awesome, everything is good. We have a helicopter, tied on the bottom of it. Let's see whether it can do that or not. Here it's not that. It has to do it, otherwise there is no backup, there is no fail safe. It's just like it has to do it. So that's what we are talking about here. Now, why the heck Titan? That's such a oddball place, so to say. Now, Titan is the only place known with liquid lakes. This is very interesting part, simply because if you remove Earth, it's like, okay, remove Earth, let's see what else we have. Almost no other place has a normal liquid, basically, running on the surface. Nothing has liquids. Flat out liquid is a rare thing in basically human solar system. So fundamentally, having a running liquid there, it's a very rare thing. That alone makes it important, because this place does not have river deltas for a previous billion years ago. No, it has active river deltas. So fundamentally, that's the interesting aspect. Another, we have already tried it, studying this puppy with Voyager probes and other probes like Cassini, and we have also successfully managed to land using Huygens probe. Now, Huygens probe was just a crash lander, so like tick, done. There was nothing else to it, but it provided enough information. Now, if you take the information that we got from Huygens and you combine them with everything else we have learned since then, and with other probes, and also the reality, it has way too many early building blocks of life. Now, we know for a fact human life, as we see it, it came from a simpler life form. Now, we can trace it back to very, early beginnings, so to say. However, there is a gap in our knowledge, so to say. Like, we know for a fact life started with chemistry. Now, early chemistry is unknown to us, simply because chemistry will destroy the thing that will create it. Basically, it's like, life itself will change planet it's inhabiting. For example, CO2 atmosphere, what the hell happened to it? Life digested it and made it into oxygen rich atmosphere. So think of it this way: life, if comes to be, it will change the fundamental building blocks of that reality. Basically, like, okay, life happened here, the planet will change on a fundamental level. So we do not know how exactly that first spark of life, so to say, happened. This puppy is the closest there is. Now, there is another aspect of it. Maybe all life requires is ingredient for life and a liquid. Now, liquid could be anything. Now, the reason for that is, we always think of liquid as water. Reason for that, water is universal solvent, and your first experience with a liquid is water. So water is very important for us. But maybe life or maybe organic chemistry is robust enough where it can rearrange itself if you provide a medium. That's why liquid is so important. Only liquid has that medium. Like, it's not gonna do anything in a gas. It's way too low density, and in a solid, again, it's not gonna move around too much. So liquid is like, perfect balance. It's almost like Thanos. So that's why it is so intriguing. Like, if we can figure out early signs of life, or maybe a fully functional basic life form, we do not expect, like, aliens or something like that. I don't think that can even be possible, but basic life form, maybe. So fundamentally, if you ask scientists who are working on this, it's completely unknown. Like, when we went to Mars, we kind of knew what we're gonna get. It's like, okay, it's almost like, sister or brother to Earth. So similar kind of rock composition, similar kind of things. This is completely different. We have no clue, no context, nothing, just zero, with active environment, with an atmosphere, with ingredients for life. So we do not know anything. So fundamentally, it's very intriguing. That's why mission was selected and chosen. And then technically speaking, it should be easy to fly there. Now when I say technically easy, I just mean that in that sense, easy as in like physics is not fighting you. It has a very thick atmosphere, which is good for propellers. It has very low gravity, which is really good for your mass consumption. So everything is quite awesome there. However, it does have some, limitations, so to say. So how the heck we gonna fly? Well, NASA tried to, first designs were of NASA was basically like a normal helicopter. Consequence of that, while you may think a helicopter is simpler compared to a quadcopter because it has only two things rotating, one rotor and another tail rotor. Problem is the rotor itself is ludicrously complex. If you look a photograph at a rotor, it's like it has gears, bevels, and like things that are moving it in such an interesting way that's like, okay, when I'm like, left side of a helicopter wing, basically helicopter body, I'll be like this. When I'm right side, I'll be like this. Like, and all that happens in every RPM. So fundamentally it's ludicrous, too many moving parts. And ask any engineer, you don't want complexity is the enemy of reliability. So you don't want moving parts. How can you achieve flight without moving parts? Like at least reduce the number of moving parts. Quadcopters. Now the quadcopter they are choosing is simply because of simplicity. The RPM you have to change, you don't have to use gears or angles or things of that nature. You just electronically change it. Solid state. Awesome. And it's mechanically simpler. Like that's why if we have any Tom, Dick and Harry can build it. And the rotor they are planning for, it's 1 meter in diameter. So it's gonna be big, significant enough thing, so to say. Now they're going for 8 rotor design, basically dual quadcopter. So 4 on top, 4 on below. Now we're like, why the heck they're doing it? Primary reason, redundancy. So in case a motor fails, in case a motor controller fails, or in case propeller breaks off, something like that happens, because again it's supposed to do all these things in an unknown world, and where there is no tech support there. So fundamentally redundancy is awesome. And another aspect is, if for example 4 rotors gives you, let's say, 40 grams of lift, 8 will give you 60. You're like, wait a minute, why the heck 8 does not give me 80? 8 will give you 80 if you space them out individually. Consequence of doing that, like spacing them out individually, makes the diameter much larger, which is, given the fact that we have to pack this puppy up inside a rocket nose cone, you can understand that. But that's why NASA did not choose that design. Even though that would be a bit more efficient, it was not compact. And utilizing this design gives us redundancy that we want. It does give us more power than 4.1, which is awesome. And it has some stability issue because of, again, the smaller your footprint, as in like airprint, so to say, it does become more stable. So there is some benefits to this. Now atmosphere is also very forgiving, so to say, because atmosphere is 97% nitrogen. Now you have to understand that your atmosphere could have let's say sulfur dioxide. Consequence of that will erode away everything you have. So you want an atmosphere that is kind of benign or inert. Nitrogen is pretty good candidate for that. It does have methane, but it's 2.8%, and you don't have to worry about flame on, simply because oxygen is almost negligible. Like you need a spectrum graph to figure out where the heck there is oxygen. It's like 0.00002% oxygen. So fundamentally oxygen is not there. So we are talking about pressure. Now you got the atmosphere, you got the pressure for it. Now pressure wise, this is the interesting part. That's why it actually has like sunset, sunrise and rainbows. That it has 1.45 atmospheric pressure. To give you a context of that, one atmosphere is around 15 psi. So this puppy is at 20 psi. It's thicker than Earth. So only place I know that is like thicker than like removing gas giant, it's Venus. So fundamentally it's very rare combination. However, all those things are super awesome. Benign atmosphere, awesome. High density atmosphere, which will make your propeller work much more efficiently, awesome. Low gravity, super awesome. It's super cold also. It's minus 179.2 degrees Celsius, basically cold enough for liquid methane. To give you an example, basically if Starship ever lands there, they don't have to make their fuel. They're like, okay, take out the pipe, fill up the tank, go. Ain't nobody got time for anything else. So fundamentally you can understand it's ludicrously cold. Now you may be like, okay, doesn't electronic like that? Well, yes, electronic does like that. Problem is anything that has chemistry, active chemistry, does not like that. For example, your batteries, they really don't like this, because battery is an electrochemical system, and the moment you cool them down, most of them are like nope. They go to nope territory, and you don't want your battery system to die in a flying system. So fundamentally you have to heat this puppy up. So, and that temperature also has another aspect. Like if you come up with a equation, it's like, okay, I need this much mass and I need this much structural rigidity for my material, and this material has to handle, let's say, this kind of load. You'll have a list, you'll have a giant list, let's say this 50-60 material that can take care of it. The moment you add this temperature, only 5 or 6 material known to man can handle this puppy. So that's why that temperature is very critical, because everything shatters at that temperature. Now, what about the power? Okay, we are planning to take flight and we need a lot of energy because again, otherwise we will freeze to death. So power is very important here. So we're gonna use solar. Well, you can't because solar is too weak. They are flat out. Simply you cannot. And even if you made a giant farm, somehow you got there. Problem would be because of the atmosphere. It's not that reliable compared to Mars situation. So fundamentally, solar is a no-go. So what do we use? We use radioisotropic basically thermoelectric generator. It's basically slow nuclear battery. That's all we are using here. Now how this puppy works is basically it has what we call Seebeck generator. If you provide it hot and cold, using that energy, basically the delta between hot and cold side, it will convert some percent, a very small percentage of that energy that is going from hot to cold into electricity. Very low efficiency. However, benefit, it has no moving part, no sound, nothing, no moving part. And the reason we don't use it on Earth simply because of low efficiency. Basically, your steam generator will give you, let's say, 30 to 40% efficiency. This puppy will give you, if you are lucky, 4 to 5% efficiency. So we don't use it. But when you are sending something into space, this puppy is very well suited for that. And another aspect, radioisotopic generators, they work for technically 30 to 40 years. So even if you launch this puppy, it takes 10 years to get there. The battery would be almost full power at that point in time, and it will still have more than enough full power for long enough. And we have tested this with Voyager probe. They have been going for 40 years and they still have power. So fundamentally speaking, this is the longest lasting battery we can build. And Titan is cold. Now this is very interesting part. For temperature delta, you want hot to be hot and cold to be cold. Now cold is very difficult to do in space simply because space is a vacuum is not a conductor. It's not gonna wick your heat away. So fundamentally dumping heat becomes an issue. When you're talking about Mars, again same issue. It's like while it does have an atmosphere where you can dump your heat, it's not that very efficient. So you're solely relying on infrared radiation. Here, or basically on Titan, that's the interesting part. Your heat will literally disappear. So basically your temperature delta will go up much more. So you should get more oomph out of it using the same generator. Basically you can take same RTG on Mars and put it on Titan. It should give you more power simply because the temperature delta is much higher. Unless the generator itself is not working at that temperature, you should only get more power. And because of the waste heat, that waste heat would be channeled into the body to keep everything else on a working temperature. So that's why I specify you need a lot of energy just to stay there. And if you use anything other than radioactive system, you have to spend a lot of electrical energy just to heat yourself up. Here heat energy is wasted, as in it's a wasted. Do whatever you want to do with it. So might as well use the heat itself to keep the chassis warm. So fundamentally that's a good idea. And RTG, while they have very long running lives, they have very low power. Basically, this puppy is supposed to be giving around 100 to 90 to 100 watts of power. That's not a lot, specifically when you're talking about flying. That's not a lot, not enough, flat out. So how the heck they cannot do that? But that power is not enough, but it is continuous. Basically, it's a slow running river that's continuously running. So it's gonna charge the battery overnight. Now, night on basically Titan can stretch for around 8 days. For example, Moon's day and night cycle goes around 15 days. So is going to charge the battery slowly. Basically most of the energy will be rediverted to battery system, and few percent will be kept for communication to Earth. And the system is very interesting because they are doing direct to home communication. So it's not gonna be using like how Huygens did, Huygens to Cassini to Earth. That's not happening here. It's like directly Dragonfly to Earth. So fundamentally amazing technology. So consequence of that, there will be some power budget allocated just for communication. But other than that, let's say in 80 watt of power is remaining, that will just go into battery and trickle charge it overnight. Once the charging is done, in daytime, it will take flight. It will drain the main battery as a primary power reserve. And the reason why it has to do everything in day, because if you want to do that at night, you have to use halogens. Again, it's not very bright there. So fundamentally, you have to do everything in day. So they're like, okay, might as well utilize that time for main work and night time for charging. Now, this only supposed to get few minutes of flight time. Do not expect that, okay, day is 8 hours, 8 days long. So they're gonna be like, oh, multiple hours of flight. No, it cannot do that. Fundamentally, it cannot. So every quote unquote day will be like, one test hop, like is every system working, everything is going. Then they will do one long hop, then land there and do every mission they can do, like with all their power equipments and all that, do that. And after that is done, like once the day is over, then they're like, okay, start charging the battery again and then do another hop. So it's going to be very slow kind of mission, so to say. And the battery bank, now the battery bank is kind of a iffy kind of situation. We want a big battery bank, so we can do multiple operations in daytime. Consequence of that, it the only way this puppy can move if it flies, and to make sure it flies, you have to keep it at light as possible. Big battery banks are not light, so people are giving me different data points about this. So it could change at this point in time. So it was gonna have around 2 to 5 kilowatt hour battery bank. It may go even larger than that if they can manage the rotor power and all that jazz. So power is kind of very tricky to balance here. Like, you want a big battery so you can fly for longer, but problem is you will consume more watt an hour to fly if you are heavy. So fundamentally, very tricky balancing act. Now, what about the instruments? Like, it's a probe. So what the hell, how is it gonna quote unquote probe the place it's going to? It has around 450 kilograms. So lighter than basically almost a ton of a Curiosity rover, but still a significant thing. Like, if you told anyone like, hey, I'm gonna thinking about making an electric craft that's gonna fly, that's 400 kilograms. They're like, whoa, that's some serious stuff. So fundamentally, it's a very big thing. And it has 2 drills, because again, you want to understand the surface. Now, you were like, why the heck 2 drills? Many Martian missions only have 1 drill. Why this has 2? Because it physically cannot move. It does not have robotic arm, so it has skid. That's how it's supposed to land, like a helicopter. So those skids have basically drills, and it's like, yeah, we do not have the luxury to move around this, might as well like use 2. And it also gives them redundancy. It's like, in case one drill bit breaks, another is there to handle the situation. And they're gonna use a lot of spectrograph, obviously gamma ray spectrograph and neutrino spectrograph. Now, problem with this puppy is they generally require a source of basically gamma radiation or neutrinos, which generally sun provides, but at that far back it does not work. And another aspect is the thick atmosphere. So whatever is coming is being absorbed by the atmosphere. So they have their own pulse neutrino generator to provide pulse. It's basically flashing light, so to say. And it also has a mass spectrograph. So once it's gonna drill, it's gonna send it to a spectrograph. It's gonna do analysis. If analysis shows anything interesting, it's like, hey, we should do more research. Then that data point will go into another heating chamber. It's gonna cook that puppy up, and then you're gonna do more detailed basically spectrograph. So basically, it has 2 spectrograph. One is for, like, doing a rough data point. Once you find something interesting, then another one will be used for more precise data gathering. So a lot of instruments is there. Basically, it's a Curiosity without a oxygen generator and all that jazz. So this was my presentation on basically Dragonfly. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.